This video, we're going to start chapter 4 in the textbook, which is on repetition and iterative control structures. So what we have on the screen here is a flow chart of what we've done so far. So we can have statements, that would do things. We can set variables, we can do math, all that stuff. We can have these decision structures. Okay, this is an if of some sort that we're either going to go this way or that way. So we have the ability to selectively execute certain lines. Okay. But the next big step for us, something that computers are well known for good reason, is the ability to repeat code over and over. Okay. So today we're going to be talking about count-based loops. There's also a condition-based loops, which we'll talk about in part 2 or the next video. Okay. So the first loop on this count control loop we're going to talk about, and in fact, the only count control loop that we have in C++ is going to be a for loop. So the basic flow of a for loop, it starts with initializing a counter and setting a range. The range is going to determine how long we stay in the loop. Okay. There'll then be a question here for each counter variable C. Are we still within range? If so, we're going to execute all of the code that we've placed inside the loop. Again, in C++, we're going to use the opening and closing curly braces to determine whether something's within the loop or not. And then we have to make sure that we increment or decrement the counter depending on which way it's going, and then see if it's in the range. We're going to keep in this loop here of code, execute, increment, test, until C goes out of range. And then we're going to move on to the rest of our code. Okay, so that's the basic overview of where we're headed. So the steps in a for loop in particular, and here's what the code's going to look like. We first have to initialize a counter variable. So we do all this inside of the for loop. So we have the for keyword, then there are parentheses, okay, that have three parts. The first part is this initialization of our variable, okay? You don't have to initialize the variable here. You could use a pre-existing variable, but it's recommended that you do initialize it here because of the scoping of variable rules that we've talked about before. So if I initialize the variable inside the for loop, it only has scope, or it only has visibility inside of that for loop. Okay, so therefore, I can make sure that if I'm in a different loop or somewhere else in my code, that same variable is not going to be reused accidentally. Okay, so again, I'm setting it as an integer. It's always an integer for our counts. C is equal to 1 is my initial condition. Okay, the next thing we have to determine what condition keeps the loop executing. Okay, or when, and it's also when do we stop when this is no longer true. So I'm going to say X is initially 1. As long as it is less than or equal to 10, I'm going to keep moving. Okay. And then this last part, these are semicolons between them. The C++ just means that's the same thing as saying C is equal to C plus 1. So C is going to go up by 1 every time. Okay. So what this means then, inside of this loop, this piece of code here will execute for C equal 1, 2, 3, all the way to 10. So it will execute 10 times. Okay. At each iteration through, the first time it goes through, C will take the value of 1. The second time through, it'll be 2, all the way up till 10. Then it will stop, and the control will move beyond the for loop, and we'll go from there. Okay. So that's the basic idea of what we're doing. So now let's take a look at some coding examples. Let me switch over to the terminal window. And I've popped up the basic C++ program for us to look at. Okay. So again, I'm going to do a for loop. I don't need any other variables. Do what we just did. An int C equals 1, C less than or equal to 10, C plus plus. Okay. I'm then going to put that in brackets. Everything inside of the brackets is inside the loop. I'm going to C out C. That's it. Okay. Let's run this one. Make sure that it does what you want. Okay, so I've got to get rid of that guy, which you don't see. That looks like I'm making things up. But anyway, I'm going to G plus that. I'm going to run va.out. Okay, so as expected, it starts at 1 and goes through 10. Okay, so one thing to watch for, we've talked about this before, are the off by 1 errors. If I wanted to go to 10, but did this instead, okay? Now I'm going to run it. Execute it first. That's weird. I have no execution line. I just did that. Huh, curious. Okay. You see that I stop at 9. Okay. It's because I had that less than. So you have to make sure your conditions are correct. Okay. Note also that we could go backwards if we wanted to. So let's say we want to count down from 10. So now my initial value is 10, and I'm going to stop. And you have options here. So I'm going to continue on as long as C, in this case, is greater than or equal to 1. Or I can just say greater than 0. That's fine too. If you want to include the 0, which you may, we would do a greater than or equal to 0. Okay? It's more readable. But this time, instead of a C plus plus, I'm going to do a C minus minus. Okay. Notice I could also do C is equal to C minus 1. That's going to work as well. But we tend to do the C minus minus to go down. Okay. Now, if I've done this correctly, we go to print it out. We see that it starts at 10 and goes down to 0. Okay. We can also adjust this in different ways. Let's say we want to go up again. So I'm going to start at 1. Let's say I'm going to start at 2. And I want to go to, let's say 100. But every time I want C to be equal to C plus 2. Okay. So it's going to start with 2. 2 is less than 100. It's going to print 2. Come back to the loop. Now the C is going to be set equal to 4 and so forth. Okay. So this should print the even numbers up to and including 100. See if I've got it correct. Can I run it? It did nothing. That's interesting. I'm glad it did nothing. We'll see what I'm doing. Not sure why I did nothing. So my C is equal to 2, which is correct. C, oh, I didn't change that. Should be less than or equal to 100. See, it was never true because 2 was not greater than or equal to 100. That was my problem. That's off by 1 errors. Get you. Run it again. There we go. Now we have what we need. Okay. We scroll up, we can see that it did start with 2 and went all the way to 100. Okay. So it's often the case where we're not going to necessarily use the 2. Okay. We can do something else with it. Okay. So if we wanted to print out not 2 directly, but I could print out the squares. Okay? So I could do a 2 times 2. C times C, I said square. Let's say we're going to go from 1 up to 10 this time. Okay? With a C++. Okay. So I can do things with that. Okay. Prints out the squares. Okay. 1 squared, 2 squared, all the way up to 10 squared. Okay. So you have a lot of flexibility with what you can do. Your programs will often have lots of code inside of here. I mean, there are lots of things that we can do. Okay. So this is not restricted to one line. Okay. We can also have nested for loops, which we'll talk about on Friday in the 3rd video. But as always with nested loops, make sure you get the outer loop working before the inner loop. Okay. And if you wanted, just to show that we can combine things, we can have an if inside of here. So if this is working, I tested that. I know that we're going from 1 to 10 by 1. Okay. I can do something like if C mod 2 is equal to 0. Okay. This is C even? This is what we're testing here. If the remainder is 0, it's even. Okay. I can see out. If I get the command correct. Even. Okay. Let's throw a tab in there. You know me and my tabs. Okay. Then we can come down here and go to the else. Put a C out odd. Oh, didn't have it. Or a little purple. So now we've got that. So C the first time through at 1, C mod 2 will be equal to 1. So it's not going to work. Okay. Actually, it's interesting with 1. I'm not sure what the first one's going to do because 1 mod 2, since 1 is less than 2. Not sure about that. Let's start with two to avoid that problem. So I don't have to think too hard. Okay. Just showing examples here. Okay. So we now do the even, odd, even, odd, even, odd. Okay. So there's a lot you can do with the for loops, and they really are a powerful item. Okay. Think about um, the switch-based menus that we've done, even with the rock, paper, scissors. We can only do it through one time. With iteration loops, either a counter controlled or condition controlled, we'll be able to have the user repeat so many numbers of times. Okay. So that's it for the for loops and for the part one video.